What is the universe expanding into? It's a question that has puzzled scientists and philosophers for generations. It's a question that tickles the brain, sparking endless debates and theories. We're used to things having boundaries, a city, neatly defined by its limits, a country, with borders drawn on maps, even our planet. A finite sphere in the vastness of space. So when we hear the universe is expanding, constantly growing, we imagine it growing into some vast empty space, a void waiting to be filled. But the universe isn't like a balloon in a room, expanding into the air around it. It's not expanding into anything external. The universe is the location. It's everything we know and can't know. It contains all of space and time, all the matter and energy that exists. Asking what's outside the universe, what it's expanding into, is like asking what's north of the North Pole. It's a question that doesn't quite make sense. There's no edge, no boundary to cross, no outside realm to expand into, no cosmic shoreline where the universe ends. The universe isn't an object floating in a bigger space. It's not contained within something else. It is space itself, the very fabric of space-time, expanding everywhere, uniformly, all at once, stretching the distances between galaxies. This is a huge leap for our imaginations, a shift in perspective. But it's essential to understanding reality, to grasping the true nature of cosmic expansion. So let's set aside our everyday ideas, our preconceived notions about boundaries and limits, and explore what cosmic expansion really means, venturing into the unknown with open minds. We'll see how we know the universe is expanding, the evidence that supports this mind-bending concept, what that expansion looks like, how it affects the galaxies and structures within the cosmos, and why it doesn't need an outside. Why the question itself is based on a flawed assumption. Forget about the edge for a moment. Let go of the idea of a boundary. Instead, think about the fabric of reality itself, the very essence of space and time. We're about to pull on its threads, to tug at the fundamental nature of existence and see what unravels, what mysteries are revealed when we challenge our assumptions. The cosmos is waiting, patiently holding its secrets, and it has some incredible secrets to share. Wonders that will reshape our understanding of everything. Ready? Fasten your seatbelts, and let's begin this journey of discovery. The biggest question in the cosmos, the one that has haunted us for so long, is about to get a little clearer as we delve deeper into the mysteries of the expanding universe. For most of history, the night sky seemed eternal and unchanging. People looked up at the stars, constellations, and planets, believing they were fixed points in the heavens. But the universe is not sitting still. It's dynamic and growing, constantly evolving in ways we are only beginning to understand. This realization began with Edwin Hubble in the 1920s, a pivotal moment in the history of astronomy. Using a powerful telescope at the Mount Wilson Observatory, Hubble discovered that many faint nebulae, fuzzy patches of light, were actually entire galaxies, island universes in their own right. These galaxies existed at unimaginable distances, millions of light years away. That alone was staggering, a revelation that expanded our understanding of the cosmos exponentially. But Hubble noticed something even stranger, a subtle clue hidden within the light emitted by these distant galaxies. The light from these galaxies was shifted toward the red end of the spectrum. This shift, a subtle change in the wavelength of light, is a phenomenon called redshift. Redshift means the galaxies are moving away from us, indicating a universe in constant motion. This is analogous to the Doppler effect with sound, where the pitch of a siren changes as it moves towards or away from you. The farther away a galaxy is, the faster it's receding, a direct relationship that Hubble quantified. This wasn't just a few galaxies, it was a universal trend. Every distant galaxy, in every direction we looked, exhibited this redshift. Each one was racing away from us and from each other. The only explanation: the universe itself is expanding, stretching like an inflating balloon. It's not that galaxies are fleeing the Milky Way as if we're some cosmic pariah. The very space between all galaxies is getting bigger, carrying the galaxies along with it. The universe is not a static stage, a fixed backdrop against which cosmic events play out. Instead, it's an active, growing cosmos, a dynamic entity constantly changing and evolving. Hubble's discovery changed our picture of reality forever, ushering in a new era of cosmological understanding. The cosmos is on the move, expanding at an accelerating rate, and we're moving with it, passengers on a cosmic journey of epic proportions. The expansion of the universe is one of the most profound discoveries in science, reshaping our understanding of space, time, and the very nature of reality. It's the first clue to understanding what the universe is really doing, offering a glimpse into its past, present, and future. And it all started with a look at the light from distant galaxies, a testament to the power of observation and scientific inquiry. So what does it really mean when we say the universe is expanding? It's a concept that can be a little tricky to wrap your head around, so let's delve into it a bit deeper. It's not like galaxies are racing through space, propelled by some unknown force. It's also not about everything flying outwards from a central explosion, like some kind of cosmic firework display originating from a single point. Instead, imagine that space itself, the very fabric of space-time, is stretching, and it's happening everywhere, uniformly, all at once. There's no single special point that serves as the center to this expansion. In fact, every observer, no matter where they are located, in every galaxy throughout the cosmos, would observe the same phenomenon, the same expansion. To help visualize this, imagine you and a friend standing on a giant rug, a vast expanse of fabric. Now imagine that this rug, the very surface you're standing on, starts to stretch uniformly in all directions. You and your friend aren't actively moving, you're staying in the same spot on the rug, but the distance between you gradually grows as the rug expands. That's essentially what's happening to galaxies in our expanding universe. They're not propelled through space. Instead, they're carried apart as the very fabric of space itself expands and stretches. Consequently, the farther away a galaxy is from us, the more space there is in between to stretch, and because there's more space stretching, it appears to move away from us at a faster rate. This observed motion isn't due to galaxies possessing some kind of super powerful engine. It's simply a consequence of the ever-increasing amount of expanding space residing between them and us. And remember, there's no privileged or special location in the cosmos that holds a unique vantage point. From the perspective of any galaxy, anywhere in the universe, you'd observe all the other galaxies moving away. The center of the expansion, in a way, is everywhere, and therefore, it's also effectively nowhere. So we're not situated at the center of the universe, because in a very real sense, every single point in the universe can be considered its center. This understanding is a profound and deeply humbling realization about our place in the cosmos. The concept of the expansion of space itself is absolutely fundamental, and it serves as the key to unlocking a deeper understanding of our universe and its evolution. And this expansion isn't some ancient event. It's an ongoing process that's happening all around us constantly right now. To grasp expanding space, scientists use analogies. Picture a balloon with dots drawn on its surface. Each dot is a galaxy. As you inflate the balloon, the dots move away from each other. From any dot's perspective, all others are receding, and the farthest move fastest. But the expansion happens only on the balloon's surface, the universe for the dots. There's no outside for them, the surface is all there is. Or imagine raisin bread rising in the oven. The dough is space, the raisins are galaxies. As the dough expands, the raisins move apart, not by moving through the dough, but because the dough itself is growing. These analogies show the universe isn't a clump of matter expanding into emptiness. The balloon's surface and the dough are the whole universe for their inhabitants. There's no empty space outside to expand into. The expansion is the creation of more space between things. The universe makes its own space as it grows. It doesn't need an external void to fill. That's the key to understanding cosmic expansion. If the universe isn't expanding into anything, what's really happening? The answer lies in space-time, a four-dimensional fabric, as Einstein described. Space and time are woven together, and this fabric can stretch. Gravity bends space-time, but cosmic expansion stretches it. Imagine a stretchy grid. Pull the edges, and every square grows. That's what's happening to the cosmos. The metric of space itself is changing. This stretching is visible in the redshift of light from distant galaxies. As light travels through expanding space, its wavelength stretches, shifting it to red. The light we see is a record of its journey through a growing universe. Even our concept of distance gets tricky. Space was expanding as the light traveled. Some galaxies seem farther than the age of the universe would suggest, because the cosmic runway was lengthening beneath them. The universe is stretching its own fabric, not expanding into something else. Does the universe have a shape? And does that shape have an edge? Cosmologists consider three possibilities: closed, open, or flat. A closed universe is like the surface of a sphere, finite, but with no edge. You could travel forever and end up back where you started without ever finding a boundary. An open universe is infinite, shaped like a saddle, expanding forever with no edge. A flat universe is also infinite, like an endless sheet of paper. In all three cases, there's no edge or outside. The universe is either finite with no boundary or infinite and unbounded. Our best measurements suggest the universe is remarkably flat. The cosmic microwave background, the afterglow of the Big Bang, tells us this. No matter the shape, the idea of an edge simply doesn't apply. The universe is all there is, no outside, no beyond. Its shape determines its fate, but not its boundaries. The cosmos is self-contained, and that's a mind-bending truth. So, what is the universe expanding into exactly? The answer is simply nothing. Space isn't just an empty box being filled. It's a fundamental property of the universe itself. Expansion happens everywhere, constantly, creating more and more distance between everything. Whether the universe is finite or infinite in its scope, the concept of a definitive edge or outside simply doesn't apply. There's no before the Big Bang, and ultimately no beyond the cosmos. This profound understanding fundamentally changes our place in the universe. We're certainly not at the center. We're just one part of a vast, ever-evolving entity. The universe isn't expanding into some pre-existing void. It's expanding, quite remarkably, into its own future. Our journey is not simply to the edge of space, but to the very edge of human knowledge itself. From our own tiny planet, we can piece together the incredible story of the cosmos. The greatest adventure of all is understanding reality itself, and we are here, as stardust come alive, to witness all of it.